We have a lot of daily experience with mirrors, but let me ask you one question. You're looking at the mirror in the bathroom in the morning, and you're getting yourself ready for the day, and you've got a kind of a smaller mirror, and you want to see more of yourself. Okay, should you walk closer to the mirror to see more of yourself, or should you walk further away, or will it not matter? So think about that for a second. Now, we're going to answer that question in 2 steps. But to do so, I do have to put in a caveat that we're assuming the mirror is vertical. It's flat against a vertical wall, so it's not slanted or tilted in any way. So if we assume that, we assume our mirror is flat against a wall, then let's try and see if we can answer that question. First, to do so, I want to say, how big should my mirror be if I want to see my face? I want to see my whole face. How big should that mirror be? So let me draw a wall. And how big of a mirror should I have just to see my face? So let me see how well I can draw a face. This is going to test my ability. So here's my forehead, and I learned in art class that your eye is about halfway down your face. And there's a mouth there. Hopefully that will make my art teacher proud. Okay, so here's my eye, and I want to see my whole face in this mirror. Okay, so the question is, how big would the mirror have to be? So by the law of reflection, we know that light as a ray will reflect off of a mirror at the same angle out as it came in. Okay, so if I were to think I need to see I need to see my hair in my eye, then a ray of light, the light bulb above, the lights in the bathroom shine light and it scatters everywhere. Some of that light scatters to the mirror and comes into my eye, and it would have to hit the mirror somewhere about there to enter my eye. Now if I draw this mark right here as being straight ahead of my eye, when I'm looking into the mirror, that's where I see my eyeball. Okay, the question is, well, how far up is this? Because this would have to be the top of my mirror if I want kind of the smallest mirror possible to see my face. This is where the top of the mirror would have to be. Well, how far up is that? Well, if I draw this line straight in, if this angle is the same as this angle by the law of reflection, and my hair is a distance h1 above my eyeball, then by similar triangles, this distance over here ought to be 1/2 h1. Okay, because I could draw a straight line across over here, straight line across over here, and this has to be the mid-bisector of that distance there. Okay, so because of that law of reflection, equal angles, then the height from my eye up to the top of the mirror has to be half the height from my eyes to the top of my head. Same thing can be argued about seeing the bottom of my chin. If I want to see the bottom of my chin, a light ray, again, my chin's not glowing, but lights from the room shine, photons everywhere. Some of them hit my chin and they reflect, scatter everywhere, but some of those scattered rays of light go towards the mirror and then bounce off at equal angles and hits my eye. So again, here's this. Those are my equal angle marks. Okay, which means going down to the point where they intersected must have been 1/2. Oops, I apologize. This should have been h1. That's h1. Okay, I apologize for that mistake there. And this would be h2 if this is h2. There we go, h2. Okay. So that means if my face is a height, I'm going to call it L, equals h1 plus h2, then the L of the mirror, or I'll do a D of the mirror, my mirror has to be 1/2 L. Okay. So that is by virtue of the law of reflection, that equal angles. Whatever angle it makes in comes out at the same angle, and we measure that from the normal. Okay, so now I know that my mirror has to be at least as big as my face to be able to see it. Now my question is, if I want to see more of my face, I want to see my hat on top of my head, and I want to see my neck below my head, do I go closer or further? Okay, let's see what happens if I go closer. Okay, so now I know my mirror's how big it is. Here's my mirror, that's half the width of my face, and I move closer. Okay, so I gotta make my eyeball right there, put my eyeball right here. Okay, and I am gonna deviate because I really stink. Give me too long. Here's my face. Okay, there's my chin. Here's my forehead. Okay, and that should be twice as big as this. Alright, so I still want to see my, how much can I see? Well, if this goes up to there, I didn't draw this very good. If this goes up to there, it's going to come out at equal angles, which means this was 1/2 H1. That means how high up it goes is going to be H1. And the same thing, that was 1/2 H2. It's going to go down H2. So even though I moved closer to it, I still can only see my face. I can't see my hat, my chin anymore. Alright? If I moved further away than this, I'd get the same effect. These angles would get smaller if I moved away, but still I've got a greater distance, so the triangle is able to reach further, and that always will give me the same viewing range. I can't see any more or any less than my face, no matter if I move close or far. Okay. Now, so in order to see my face, I just need to tilt the mirror. Okay, that would be an easy way of doing it, or get a bigger mirror so I can see a bigger range. But the interesting thing is we often think, oh, I just need to move closer, or you might think I just need to move further away. But the law of reflection, how simple it is, and our daily experience causes us to question what we thought was purely intuitive. But with the rigor of the theory now, we can do some pretty complex imaging to understand how light really works and what we really observe, and then to do things that we might not be able to do, or might not be able to understand at this moment, but be able to do some cool optics that might have some important applications. Okay.